So next, let us look at what a symmetric relation is. So again, if R is a relation defined on set A, that is R is defined from A to A, R is said to be symmetric if A comma B belongs to R implies that B comma A also belongs to R. That is, if for every element A comma B which is in R, if B comma A also belongs to R, then we say that R is symmetric. For example, if you take R is a relation defined on n to n, and R contains elements x comma y such that x square plus y square is equal to 25. So if this is the definition of the relation. So if you draw the diagrammatic form of this relation, this is set of natural numbers. The set of natural numbers R connects these two sets. And what is the definition of connection? 1, 2, 3, 4, 5, so on. So an element x is connected to an element y if and only if x square plus y square is equal to 25. So 1 is 1 square plus any number square give you 25? No. So we know that x square plus y square is equal to 25 will be valid only for 3, 4 and 4, 3 in the set of natural numbers. So as you can see, if 3 comma 4 belongs to R, the reverse of that 4 comma 3 also belongs to R. And 4 comma 3 belongs to R, and 3 comma 4 also belongs to R. So for every element of the form A comma B, B comma A should also belong to R. So that is called a symmetric relation. Now let us look at one more example. So let us take this example. R is defined from the set of lines to the set of lines on the plane. So if you take a plane, Cartesian plane, we know that you can draw a lot of lines. So R is relation defined from the set of lines to itself. And R connects the line L1 to line L2 if and only if they are perpendicular to each other. If two lines are perpendicular to each other, R connects both of them. Now, is this relation symmetric? So let us check whether this relation is symmetric. So as you can see, what is the definition of symmetric? If A is related to B, B should be related to A. So if A is related to an element B, B should also be related to the element A. So does that logically hold good for this relation? So if you take two lines L1 and L2, if L1 is perpendicular to L2, can you say that L2 is also perpendicular to L1? Yes. So L1 perpendicular to L2 implies L2 is perpendicular to L1. Hence, if L1, L2 belongs to R, L2, L1 also belongs to R. Now, as you can, how do I write it mathematically? So let us say that I say let an element of the form L1, L2 belong to R. So if an element of the form L1, L2 belong to R, L1 has to be perpendicular to L2. L1 has to be perpendicular to L2. And this implies L2 is perpendicular to L1. So if L1 is perpendicular to L2, L2 is perpendicular to L1. And this implies L2 comma L1 also belongs to R. So if L1, L2 belongs to R, L2, L1 also belongs to R. Hence, R is reflexive. R is symmetric. R is symmetric. So what is the question that you need to ask? If A is related to B, is B also related to A? That's the question we need to ask. So if you take another example, so R is a relation defined on the set of human beings to set of human beings, and the definition of R is a brother of. Is a brother of. So is a brother of, is it a symmetric relation? The answer is no. Why? So if you take a human being 1 and a human being 2. So let a human being 1 and human being 2, this ordered pair, belong to the relation R. This implies H1 is a brother of H2, then only H1 and H2 belongs to R. So if H1 is a brother of H2, can I say that H2 is a brother of H1? So can I confidently say this? You might think that this, yes, I can say this, but no. If you look at it carefully, if H1 is a brother of H2, is it always true that H2 is a brother of H1? No, because H2 can also be a sister of H1. If H2 is a female, if H1 is a brother of H2, H2 is not a brother of H1. Sometimes it is possible that H2 is a sister of H1. Alright? So H1 related to H2 does not imply that H2 is related to H1. So this does not imply this. Hence, this is not symmetric. So I hope you understand what a symmetric relation is.